So far, our actions have been of a synchronous nature as we've worked through problems in this class. And what I mean by that is our client-server relationship. Whenever we've sent a message from a client to a server requesting something, we have sent an HTTP request. The server has serviced it and given us back whatever we needed in a response. We've talked about lots of ways to do this using GET and POST and patch and put. We've talked about using it for RESTful APIs and sending back web pages, sending back CSS, JavaScript, and images, all kinds of different types of resources. But one thing has always remained the same. We asked for a resource, the server thought about it, did whatever it had to do, and responded with the resource that we asked for. The browser then used that resource in whatever way we originally intended. If it was an HTML page, it replaced whatever we were looking at. If it was a REST call, it returned some data. Now, going forward, we need a way to grow our applications. Web applications and desktop applications used to look very different, and this was because of the synchronous nature of the web. When you go to a website, if you think of just a static web page and you navigate from page to page, this is a good representation of the synchronous web. This is a good representation of the standard issue relationship we've been using so far when we make a request to the server and get back a response. Think about it this way. We can even use some JavaScript to try to augment some of these things, but at the end they're the same. Remember when you built in the event on your first home screen that listened for the spacebar event, and then once you press the key for the spacebar, it would then change the page and send you to the main menu. While this was actuated by JavaScript and used the DOM to actually change the URL, instead of the user, say, clicking on a link, it was still a synchronous action. All we did was automate the process of requesting the URL. Once we did that, it still made a round trip to the server and brought back any resources it required to generate a new page and load it on the client. Now, what is the alternative? The alternative is a way to generate a request from the client, send it to the server, and elicit some kind of portional response. Maybe we just want a little snippet of HTML to change one element of the page. Maybe we just want to change the size of an icon or replace an icon with another one. Maybe we just want to get some data because something has changed in our game. But we don't want to reload the page, we don't want to change it, and we don't want to have the user sitting there scratching their head waiting for something to happen. We've become accustomed to this in the World Wide Web. If you think of any major social media site, they all work this way. When you go to Facebook or Instagram or any social media site, when you scroll, you don't get a whole new page every time you scroll through 10 items. You get a little kind of swirl for a moment, and then 10 more items appear below the ones that you've looked at. What you're seeing there is an example of asynchronous communication. We're not leaving the page and going to another one. We're just requesting the next 10 elements so that we can add them to the page we're on. While this seems intuitive and natural now and almost required, it was not always this way. So what brought it to this place? What got us here is a concept called Ajax. Ajax does stand for Asynchronous JavaScript and XML, or at least it did for most of its life. Recently, some people have kind of dropped using it as an acronym for this, but in reality, it was this way. The reason why it's kind of fallen out of favor is because of the last part, that it includes XML explicitly. And today, more often than not, people are probably using JSON. But regardless of the transport method of how you mark up the data going back and forth, the concept is still the same. If I ask you on a test or quiz what Ajax stands for, I do want you to know that at least historically, it stood for Asynchronous JavaScript and XML. What we're doing here is using JavaScript to transport information back and forth to the server so that we can use the DOM to make changes on the client side. And we'll see how these pieces all come together as we go through. This is not a standalone language or technology. Ajax is not a language. It's not like JavaScript or C# or something like that. Ajax is a set of best practices and libraries that we can use within existing technologies to achieve a result. And the result we want to achieve is to facilitate asynchronous communication. This is also a client-side technology. That's very important to remember. The server side in this only is concerned with actually fielding the request, just like it would any other request, by the way, synchronous or not, and responding to the request with a response. Everything that happens that makes this magic and it not reloading the page is actually done on the client side. Server side, all you need is, just like any other server side, you need the facility to respond to the request. So why would we do this? What is the purpose of this extra complication? Well, the real purpose is that for the user, it's much more interactive. It becomes, in a sense, as much as possible, as close to a desktop application as it can, and less so a website. If you could imagine that using a social media site was more akin to navigating a static website, I think you could see that it would be a lot less gratifying experience. You would probably be a lot less apt to even use a social media site because that would just make it clunky and unwieldy. Most things we're building today are not static in nature. They are in fact dynamic. And an asynchronous communication paradigm fits this much better. If we can make our web apps actually act like applications, we are expanding on the benefits of it being a web app, namely that it can be written once and used anywhere, all kinds of platforms. I don't have to do updates to all these different things like Android and iOS and all this. I can just manage it in one place. It's accessible. You can even get a web browser for refrigerators nowadays. So being able to maintain your most powerful version of your application on the web is hugely powerful. And to get us there, we need asynchronous communication. So let's break down the individual pieces that make up Ajax. So the biggest part is JavaScript. And we're going to use JavaScript both to send the message and to receive it. So we're going to make the request with JavaScript. This is not all that dissimilar to how you've used JavaScript to possibly make requests before in a synchronous manner, but we're going to use additional JavaScript libraries like Xmlhttprequest or fetch in order to help automate this process and make it asynchronous. Once we send the request, though, we're still going to rely on JavaScript to actually also field the response, because here is where we're taking a big divergence from the standard synchronous approach. With the synchronous approach, we can rely on the built-in mechanisms often of the browser to deal with how the response is handled. However, in this case, we are kind of circumventing that mechanism, and we are asking the server to send the response directly back, where our code is going to listen for it. Once it comes back, then it is our responsibility as the programmer of the asynchronous request to field that response and act on it. We also need a medium like XML, JSON, YAML. Make something up, it doesn't matter. But we need a way to transport information back and forth from the client to the server in a way that when we receive the information, we'll understand it on either side. We also need a server-side technology. Now, we're obviously using Node.js, but this works in any server-side technology. PHP, .NET, Java, Rails, anything. It honestly doesn't matter. What does matter is that you realize that the server side, again, only plays the role of servicing the request. The fact that the request happens to be asynchronous in nature doesn't change what the server needs to implement it. It might change the logic of how it's implemented and how it generates a response, but the server is still doing what the server does. It is still fielding an HTTP request and issuing a response. That hasn't changed. The only thing that's different, and the server doesn't really care about this, is that the request came asynchronously instead of synchronously. So when we build an Ajax request in JavaScript, we're going to usually want to build out some kind of function to handle the request. Often this will be kicked off by an event. So maybe the user interacts with the page, or the event could actually be a timer or a response coming back to the server or to the client from another request. But there'll be some type of event that will happen, that occurs, that it causes our JavaScript function to run. Our JavaScript function is then going to use special libraries that basically encapsulate the HTTP communication mechanism and allow us to create the request to send back to the server. Similarly, that same function will then have a mechanism in place to listen for the response that will come back so that we can act upon it. Once we get it back, we're going to use the document object model if we need to change the HTML in any way. Remember that we can use items like get inner HTML and get element by ID to look for different parts of the DOM and change it. Here's a visual on how this is all happening. So in the beginning, some event occurs in the browser. In our function, we're going to create, in the original version, and we'll talk about fetch a little later, an XML HTTP request object. This object is named after the original library that allowed asynchronous communication to take place through JavaScript. Once we create the request, giving it all the parameters it needs to set up its header and possibly body, then we send the request over HTTP, just like we would for synchronous requests, to the server. Whatever endpoint we've set up on the server receives the HTTP request and processes it, just like it would for a synchronous request. It then sends the response that it's created back to the browser. Just like a synchronous request, the browser receives the input, but this time the browser ignores it because it wasn't meant directly for the browser to change the page. However, within the browser, your JavaScript code is listening for the response. Your JavaScript code sees the response comes back, checks that it is of the correct type, and that it has a good action code like 200, okay, and then it will maybe update the page content or carry out whatever action is required once this is returned. So let's talk about the XML HTTP request. This is the interface through which we can make HTTP requests as if we were simulating the browser working this for us. This was actually been around for a long time, much longer than it's been in use for Ajax style requests. And unlike almost everything else, it had an unlikely source. It actually appeared in Internet Explorer in the late 90s. The reason why this was put in was as a clever mechanism to help make forms a little bit more intelligent. The thought was that as you're typing in a form, wouldn't it be great if the form could check some things to let you know as you filled it out, possibly if you had filled it out incorrectly, before you filled the whole thing out, hit submit, waited for the server to chew on it, sent it back, and said, nope, sorry, you missed the second out of the 10 fields you filled out. It would have been nicer if maybe the form could tell you that as you filled out the second field. So that was the idea initially behind XML HTTP requests. It was going to be a clever way to make forms a lot easier to use. It both sends a request and it parses the response. But it's a little bit clunky, and maybe a lot of bit clunky, but it was a good place to start. Once it appeared in IE, it wasn't very long before all the other major browsers also picked it up. And it became a standard much later, but it took a little while for it to really pick up as to getting real use beyond some form validation. So the main kind of adoption wave really came after a cool little feature appeared in Google. You've probably seen this feature yourself and probably not even given it much thought, but it wasn't always there. As you type something in Google, the look ahead feature looks at what you've typed and it's asynchronously sending it back to the Google servers so it can make suggestions on what it thinks you might be implying. So if I start typing Marist and I type M-A-R, it might decide that there are possibilities that I might mean, and it might give them to me as an option that I can click on to finish as a suggestion. And they're a little bit even smarter than just looking at the first 3 letters in common searches broadly. They'll even look at common searches that I as a user have made if I'm logged in and they have that information to tell Brian that maybe MAR is Marist because that's something important to him, but for someone else MAR mean something completely different. Now this when it first appeared was the first really publicized use of XML HTTP request, and people just fell in love with it. They saw it and they were like, this is amazing, because the page wasn't refreshing, and believe it or not, that was a big thing back then. And once that happened, it gave people a lot of good ideas on how they could use this technology in all kinds of sites, and it just kind of ballooned from there. Let's look at an example of how we would actually use XML HTTP request to create a request and send it. In this case, we're going to start with a really basic one that actually uses a text file as the contents of the asynchronous request. It's going to be this Ajax info.txt. But we're going to take the contents of that file and insert them into an HTML page. So in the beginning, we're going to start with 3 files. We have ajax.html, ajax.js, and ajaxinfo.txt. Again, this is the content that the server is going to send back to us once we request it, so that we can insert it into the HTML here on the client side. This is the HTML file. You can see here it's very basic. I left the head out. We just have the body here with a div called demo with the header 2 that says do not press the button, of course, as a joke, and then a button that has an ID of change button and some value here that it will show on the button. And we have a link to our script in Ajax.js. The text that we're going to send in the Ajax info from the server looks like this. Notice it's a snippet. There's no declaration of the HTML here. There's no header or HTML tag. It is just a div. So this is what's referred to as a snippet. I didn't even mention HTML as an option for transport of your asynchronous requests along with JSON, XML, and YAML, but it absolutely is. And in fact, in the third part of the project, it's one that you would use. In the third part of the project, part of it on the setup screen is to change out each setup screen as you move through. This is actually an example that you can adapt to that purpose. So this is just a div with the ID of demo. It has a header that says you press the button and a message in these paragraphs, and that's all. The JavaScript now is pretty straightforward. We have a variable here named change button that is just going to be our JavaScript representation of the DOM object that we're going to get by element by ID here called change button. So that's our button. And then we're going to add an event listener to our button called click. Notice that if I go back to the HTML here, the button didn't actually have any event listener on it. We're using a nice semantically clean approach to doing this. So we're going to add a click listener with our W3C add event listener, and we're going to give it the function that we want it to call when I do click. Now this, the load doc, is that function. So when I click the button, it will load this function. Here I'm going to instantiate an XML HTTP request. This is that library that was given to us when First Explorer and then all the other browsers wanted to make it possible with JavaScript to actually manage the HTTP connection lifecycle. So XML HTTP request is a library that's available to you in JavaScript, just like a lot of other libraries. In a sense, it's no different than using console log. You didn't write the code for console log. You're utilizing the code from console log to log out your messages. XML HTTP request is a library that you're going to utilize to make a request. Now that we have it, we're going to open it This is a method on this object, and we're going to send a GET request as opposed to a POST, a patch, a put, or a delete. We're going to send this text file, the Ajax info.txt, and we have here a false. We're going to come back to what this false is in a moment, but this parameter is actually pretty important to our conversation. But for right now, we're going to move past it. Once we've created and instantiated the request here, we're going to send it. So this request.send is a method that sends the request. This null represents what I want to put in the request body. Now, notice because I made this a GET request, I don't actually have to put anything in the body. I'm asking for a GET request. I'm giving it a URL I want to get, which is this ajaxinfo.txt. And I don't need to send a body because it's a GET. If this had been a POST, I would probably have something here that I would be sending as part of the body. Now here, I'm going to alert, which we all know is that annoying modal, the request response text. So when this thing returns from the server, when we hit send here, it's going to wait, send the request to the server, it's going to wait here, and then when it comes back, this will alert the text. Okay, so let's look at the response. So this is what we get back. We get back a modal, and it says that the localhost :8080, so this was done on your local machine calling to your local server, but if you had called to another web server, this would be different as far as what host and port would come back. And it says the contents of the file. So what it gave back was the contents of the file that we requested, which makes sense. If we had made a synchronous request for a text file, we would get back the contents of that file as well. We called it a text file because it's just a snippet of HTML. But you can imagine that if you had a div or some element in your HTML that you wanted to change, you could change the inner HTML of that element to be this, and you would be in effect inserting this HTML into your existing HTML document. Again, no page refresh would be required to achieve that. Now, why I mentioned that false parameter, and I said we would come back to it. Well, this request was in fact synchronous. Even though we were using the Xmlhttprequest library, which I said we would use to make asynchronous calls, this was in fact synchronous. And we can tell that because when we sent this, I said also that it waited here, that it waited for the response to come back. Because if it hadn't, it would have just run right through, and this request here would be empty because we hadn't waited for the response to come back. So what would this look like if we used it as it was intended as an asynchronous request? Well, the first thing we need to do is change the last parameter to true. This makes it an asynchronous request. Now, if we run that same thing, just changing this one line of code and changing this one part, notice here that what we get back is empty. And this is empty because, again, we ran that line of code right after we sent it. So if we look at the line of code here, we send this, and we then alert immediately the response. But we know that actually sending a request to a server over even a local network takes orders of magnitude longer than it does to run the next line of code. So this is empty when we actually run it. It's not till some point in the future when the server actually responds with that little snippet of text that I can actually see what's in here. So how would we go about doing that? How would we go about making sure we see the response? Well, remember when we discussed the onload event listener and we said that this was a good way to make sure that your page was loaded before you ran any JavaScript? Well, just like we did that with the page load, we can use the load event for anything. It doesn't have to be just the page. In fact, we can use the load event of the request. So every time there's a new event on the request where it's loaded, we can run some function. So let's take a look at how we might use this in an asynchronous example. Here we have our same load doc function that we had before. This time, we're creating the XML HTTP request. We're opening it the same way with the exception that we have a true here for an asynchronous request. But now, instead of just sending it, we're first adding a listener. Now it's important too that we add this first, just because we don't know how quickly things will happen. So we add our load, and our load event will fire this function. This function looks at the request status to see if it's less than 400. So if you remember the HTTP status codes, what we're looking for there is to see, is this less than a 400? A 400 meaning like a 404 where page not found, or 500s meaning there was some server error. Essentially, we're saying it's okay if it's a 200, which obviously we want, and 300s, which are redirects, we're going to take those too. So we're just kind of being a little bit lazy here and giving a blanket okay to anything less than a 400 as an HTTP status code. Assuming that's true, we're then going to do what we did before when it was a synchronous request and alert the request response text. Notice here that after we've defined this function and added it as an event, then we send the actual message. Once we send this message, this function is actually done. It's only because we added this event listener that this comes back and works, because the event fires, because we've assigned it, this function happens when it comes back, and then we get our response. There are other request events that we can use as well. So you've probably noticed those little swirling wheels or other interesting kind of visual effects that often things are given when asynchronous actions are happening. You can use those with the progress event on the request, because it will get updated as progress happens, and then if you want to show like a little bar going across, you can do that. There's also an error, so you can look for errors, and an abort, so you can look for abort as well. All right, let's see what we can do with a little bit more usefulness than actually just having a modal pop up once we get the data back. Once we get the data back, how can we maybe use it to change our DOM? You already know how to do this, even if you haven't kind of put it together yet, but you've seen this part before. This line of code should actually look very, very simple. So here's the same code we had before. We have our load event. Here's the function that fires when that event happens. We check for a 400 or less than a 400. And here we get an element by ID. In this case, it's an element called demo, which you might remember was just a span or a div that we had. And we set its inner HTML to be the response text, which we saw in the previous modals is that snippet of HTML. So in doing this, you can see here, this is no longer in a modal. It's actually the replacement HTML that gets put on the screen. Let's also see how we might do this if we don't send a snippet of HTML, but instead send some JSON. This is a JSON object we've used before. It represents me as a person with my first name, last name, and an array of cars that is very much out of date. And I can take this now and send it, instead of having that text file, let's put it in an Ajax info.json file. We do the same exact thing where we make a request, but instead of requesting the Ajax info text, we request the JSON version. We set this to true to make it asynchronous. We give ourselves a load event listener and attach this function to it. The only difference here is that because it's JSON, we're using the parse function to ensure that we parse this correctly from the response text. So this response text will be pure text, but we're going to know that we're going to get it as JSON, and we want to apply parsing it as JSON. And if I bring this up in the console here, because we did console log it, in the browser you can see here that I do in fact have my JSON. Okay, so bringing this full circle, how could this be used in our projects? So if you imagine from project 1, you have some kind of client-side event that happens that calls back to the server. You created lots of routes for that on the server side. Let's say that we create a route on the server side similar to our APIs called game screens. So this is for our setup screens where you go through and you go through the entire setup, where you pick your profession, if you're going to be a banker or a carpenter or a farmer, and then you give your your players names, and then you pick a start month, all of those things that you go through in the setup. If we had a URL that got a game screen, which would return the little snippets of each HTML for each of those screens, and took a parameter which was, say, the index of a array that would contain that information. So 0 would be the first screen, 1 would be the second, 2 would be the third. We could send this API call back to the server and have the server return to us the correct snippet of HTML based upon what ID number we put here. Once we get it back, then we can actually use DOM manipulation to update the screen.